So let us see one more problem on super mesh. How do we solve? But here with respect to dependent source. So I am Professor Mohan PS, Assistant Professor, Department of EEE, SJBIT. So here they've asked us to solve for IX, and I want to be very cautious in seeing the question because they have not told explicitly you can apply super mesh. So they tell you to apply mesh. It's up to us to analyze whether it is normal mesh or super mesh. So here 2IX is a current source. Depending on current, it's a super mesh. So let us take the currents in clockwise direction as shown, I1, I2 and I3. So now I want you to pause the video and analyze which meshes are super mesh and what is the constraint equation. So we write the constraint equation for the dependent current source, current dependent current source, or dependent or current source depending on current is for 2IX. So the unknowns are the mesh currents I1, I2, I3, and using that we'll find what is IX. So I1 by inspection we can say it is plus 12 and not minus. Why? So I1 is going in clockwise direction. It is going down through 28, moving left to the wire and going up through 12 amperes. Thus both are in same. We write I1 as 12 amperes. So thus you will not be applying mesh current analysis here, because by mesh current analysis, either by mesh or normal mesh, what is your byproduct? What is the end result? You'll be finding out currents. Thus only by inspection we have found the current I1, the circulating current I1. Thus will not be applying mesh analysis to 12 ampere or for mesh 1. Thus we have two unknowns and we need two equations for solution. So one is your constraint equation, right? So what we discussed in the concept video of super mesh, what should I take, right? So we write the constraint equation as 2ix is equal to I2 minus I3. I hope you are aware why we are writing so. So I call this as equation 1. However, the variables are for the unknown I1 and I2 and I3. I1 is known, so the variables are I2 and I3. So in equation 1 I should have only I2 and I3. If I get I1 I can substitute as 12. I repeat, in my equation 1 I should have two unknowns, those are I2 and I3, and by chance if we get equation in equation 1 as I1, you substitute the value as 12. So in equation 1 we have got the variable ix. So we have to replace this ix. So what exactly is ix? Ix can be written or is written or should be written as I1 minus I2 only. Why? Okay, if you are not sure, you can refer the previous videos on mesh or super mesh. How is it I1 minus I2 only and not I2 minus I1? So substituting that in equation, we can rewrite the equation as 3I2 minus I 3I2 minus I3 is equal to 24, and that is my first equation. I repeat, the unknowns are I1, I2, I3, but we have found I1 by inspection. So there are two unknowns I2 and I3. So we need two equations, out of which one equation is the second one. So let's see the other equation. So let's apply super mesh. How do we apply super mesh? Remove the current source element completely, which is responsible for super mesh, and then apply the super mesh in clockwise direction, right? So now writing down the KVL for mesh 3 and mesh 2 simultaneously. This is our equation. That is 4I3 plus 8I2 plus 28I2 minus 28I1 is equal to 0. Now what should we do in the next step? What should we eliminate? Yes, you're right. You have guessed it rightly. As discussed, I1 should be substituted as 12 amperes. Why? Because the two unknowns are I2 and I3 only. Thus, we have the third equation. So these two are the equations. That's equation 2 and equation 3. So solve them using calculators, and you'll get the answer as 9 amps and 3 amperes. Right. So now, how do we find Ix? So as shown in the equation for Ix is equal to I1 minus I2. So substitute those two, you'll get the answer Ix is equal to 3 amperes. So that's how we solve using super mesh. So what was this problem? Was it a normal mesh or super mesh? This problem was with respect to super mesh. And how do we decide whether it's a normal mesh or super mesh? If I have a current source, either dependent or independent, linking two meshes, then we call those two meshes as super mesh. And how do you write super mesh? Constraint equation and then apply super mesh. So thank you for watching the video. So please do subscribe for the YouTube channel to enhance your knowledge further.